All right, good morning. So today I want to talk about some log rule reviews and an additional log rule that I don't think we talked about last year, as well as compound interest. Compound interest is just a standard that got added this year. It's really just, depending on the problem, it's just a geometric series, or it is, just using logs. It's just exponents. It's not difficult. Yeah, okay. So like you remember me saying and you making fun of me last year, in IB, it all comes down to 3 log rules. That's really all they are. It's where if you have a sum of 2 logs of the same base, you can make them 1 log and multiply. Then kind of vice versa, where you have a difference of 2 logs of the same base, you can divide the insides and make them 1 log. And if you have a log of something raised to a power, you are allowed to move that power and make it the coefficient of the log. I'm not going to get into showing why. I showed that to you last year. You remember. This change of base formula is for any log. So like any log base A of B can be written as the division of log of C of B over log C of A, where C is absolutely anything you want it to be. It could be any base, doesn't matter. And then the last thing we're talking about today is compound interest. It's just a pretty basic formula. It's your starting amount, what you put into it, times 1 plus R over 100K, all to the Kn. So what are those letters? R is the interest rate. This is the way it's written on your formula sheet, so that's why I copied it like this. I mean, R over 100 is just like if it's a 5% loan or 5% interest or whatever, you just write it as 0.05. This is just 5 over 100. It's the same way it was written for studies in the past, so that's how you read that. And K is the number of times it is compounded in a year. So like if it's just compounded annually, K will be 1. If it says like compounded quarterly, K will be 4. If it's compounded monthly, K will be 12. And N is the number of years that you're dealing with. So yeah, let's just go ahead and start doing some examples. So let's do 2 log problems. These will go pretty quickly. So first one, we're just solving a log equation. So we have log 6 of x plus log 6 of x minus 5 equals 1. So log rule number 1, we are allowed to put those 2 logs together as a product. So x squared minus 5x, all in the same log, equals 1. So now we can just convert this to exponential form. So 6 to the first power is equal to x squared minus 5x. So 0 equals x squared minus 5x minus 6. So 0 equals x minus 6, x plus 1. So if this was just an algebra problem, our answers would be x equals 6 and x equals negative 1. But you have to remember, well, I should probably check my answers to see if they make sense. If you were to plug in negative 1 back into this equation, you'd have log 6 of negative 1, which isn't a thing. You can't do log of a negative or 0, if we remember. Because, I mean, it makes sense. It's like 6 to what power equals negative 1? That's impossible. So that doesn't work. Our only answer is x equals 6. If you plug in 6, it doesn't cause any problems. All right, example 2, it just says evaluate, so we're just going to simplify as much as possible. So first thing I notice is this 1/3. We can move this 1/3 into the exponent of 27. So we have log 2 of 48 minus log 2 of the cube root of 27. Well, the cube root of 27 is 3. So we have log 2 of 48 minus log 2 of 3. Log rule number 2, we have a difference, same base, they're both base 2, so we're allowed to take the insides and divide, so that becomes log 2 of 16. So now we're just asking ourselves 2 to what power equals 16? That is 4. All right, and we're done with that. So let's, undo. Let's scroll up. So now this one's going to be a little more complicated, but I wanted you to see it because it's going to involve converting to a quadratic equation as well as using change of base. Because if you look at this, I can't combine these two logs in any way because this one's base 3 and this one's base x. So what I'm going to do is say, okay, I'm going to convert the second log to base 3 using the change of base formula. So the 4 just stays a coefficient. So it'll look like that. Now, if you remember, log 3 of 3 is just 1, so that's going to go away. And off to the side, I'll tie into a rule. I'm going to erase this in a second, but here's another rule if you want to write this down. Log A of B is equal to 1 over log B of A. If you look right here, that's what happened. We took this log x of 3, used the change of base formula, and got to here, but this log 3 of 3 is just 1. So this is just going to turn into 1 over log 3 of x. So here's a rule if you want to write that down. Okay, I'm erasing it now. For space. Okay. So this isn't super helpful yet because this right here is in the denominator. That's not super helpful. So what I'm going to do is basically multiply every expression by log 3 of x. So hopefully I can write this as one step and you'll follow it. So if I multiply the first term by log 3 of x, it just becomes log 3 of x squared. And then if I multiply the second term, it cancels, leaving me just 4. And then the third term becomes 3 times log 3 of x equals 0. So IB likes to ask questions like this that look similar, where you have an equation, and then all of a sudden, if you notice, it really just turns into a quadratic. So think of log 3 of x as, we'll just make it a different variable. We'll make it y. So if I were to rewrite that in terms of y, it'd look like y squared, I'll go right ahead and write this next term next, plus 3y minus 4 equals 0. So all I did was substitute the log 3 of x and rewrite it as y for now. Now it's just a quadratic, so we factor, so what would that be? That would be y plus 4, y minus 1 equals 0. So we have y equals -4 and y equals 1. Well, we just said y was equal to log 3x. So really we have log 3x equals -4 and 1. So to solve for x, you're really just doing 3 to the -4 equals x and 3 to the first equals x. So that gives us x equals 1 and x equals, well, I'll write it out, 3 to the -4th, which is really just 1 over 3 to the 4th, which is just 1 over 81. So our two answers are 1 over 81 and 1. Alrighty, so that's that. Hope that made sense. Alright, so now we're going to do 2 compound interest problems, and we're going to call it a day. So compound interest isn't hard, but I just wanted you to see it. So in this first problem, we have Miss Aubrey takes $600 to the bank, and the bank offers 4% interest compounded annually. and we want to know the amount of money after 8 years. So that would give what do we want to call it? What does IB, hold on, sorry. What letters does IB use? Final value. Okay, future value. So, okay. So, future value would equal our initial investment, $600, times 1 plus, I'm just going to immediately write this as 0.04 for interest over, this one's just compounded annually, so that represents 1, and then I'll put the 1 in here for this first time again, and then times 8, because it's 8 years. So then we just do that multiplication, so 1.04 to the 8th. So it would make $821.14. Okay, so that's what you would get if you compounded yearly for 8 years. All right, so then it says after 8 years, Ms. Aubrey takes her money out and invests in a different fund that's 4% compounded monthly. Okay, so our future value would be our new money amount times 1 plus 0.04 over 12, because it's compounded 12 times per year, and then 12 to the 12t. So, and then, we know the amount is 5 years. So it's really to the 60th. So we just type that all in. And when we type that all in, we get an amount of $1,000 or $1,002.61. There we go. All right, one more problem and we are done. So for our last problem, Ms. Kira is investing $3,000 into a savings account that offers 5% interest compounded quarterly. We want to know how long will it take for her money to double. So we know what that doubling amount would be. So we want to know when will she have $6,000. So we set that equal to our starting amount of $3,000 times 1 plus 0.05. This is compounded quarterly, so divided by 4, and then to the 4t. So we are solving for that t, how many years? So first step would be divide by 3,000, so 2. So let's just rewrite that parentheses. So 0.05 divided by 4 is 0.0125, so this could be rewritten as 1.0125 to the 4t. So to get rid of, or to isolate the exponent, what we need to do on both sides is to take the log of 1.0125. So we'll put it up here. Log 1.0125 of 2 would equal 4t. Because if you take the log of that of the right side, that's just going to cancel. So all we have left to do is type this log in and then divide by 4. All right, and when you do that, you get, t equals 13.9. So, but well, not necessarily obviously. It's not going to compound at 13.9 years. It's going to compound and get there at 14 years. So it takes 14 years for Ms. Kira's money to double. All right, that's it, and I'm out of time. So hope you all have a great day, and talk to you later.